We're building a solar electric catamaran to live on and to travel the world. We've designed it from scratch so it can go further and faster than any other solar catamaran on the market. But such a custom boat needs an equally custom control system. So I built one, and the interface that controls it. It integrates, monitors, controls and automates all of the boat's systems. The best way to show you the system is as if you were coming on board the boat and experiencing it in real life. Hi, I'm Tess, and together with my husband Rob, we've taken on the challenge to design this solar electric boat, as well as the control system that runs it. The idea behind the boat was to travel the world without the noise, fumes and vibrations of a diesel boat, but also without the hassle of managing sails. When we started looking at our options in 2021, we quickly realised that there wasn't anything on the market that would really give us the performance that we wanted. And the benchmark for our performance was to be able to do 100 nautical miles a day on electric only, around that 7 to 8 knots mark, and to be able to do that again every 3 days. In practical terms, what that means is that we could circumnavigate Australia, which is about 7,500 nautical miles, depending on how many stops you make, in less than a year without using any diesel. So that's become our benchmark for designing the system. We're both experimental physicists, so we're definitely up to the challenge.
And you know about that stuff?
Penny. I'm a physicist. I have a working knowledge of the entire universe and everything it contains.
Who's Radiohead?
I have a working knowledge of the important things in the universe.
The concept for the boat was really Rob's. He designed the electrical and propulsion architecture for the boat. He found the right combination of products that would create an optimised system that would really give us the performance that we wanted. It then became my job to make those components talk to each other and to make sure that they would operate together seamlessly and robustly, as well as to design and build the user interface. And then we gauged a boat builder with a fast, slender, lightweight catamaran hull to do the actual physical build. This is our boat. It's 68 feet long, 37 feet wide, and has over 23.9 kilowatts peak of solar on the roof. These then charge our 254 kilowatt hour battery. That's a 700 volt propulsion battery. And then we also have almost 20 kilowatt hours of boat systems battery at 24 volts. Our boat moves under the power of our 2 electric engines, which at 700 volts and limiting them to 1C discharge rate gives us 127 kilowatts on each side. Those engines are then backed up by 2 400 horsepower diesel motors. Operating a large boat such as this is not only about the engines though. It's about managing dozens and dozens of systems, things like water and waste and power, sensors, navigation gear, lighting, cooling. The larger the boat, the more of that equipment there is and the harder it gets to manage that manually.
It's no good. There's too much data.
So to make it reliable, safe and easy to manage, we used a digital switching system. But unlike other boats, we actually use a digital switching system to run our electric propulsion. Before we dive into the details, let me give you a quick primer of what digital switching is so that you have the context that you need to understand what the system can do. Digital switching is basically the modern replacement for a boat's fuse box. Instead of running every wire back to a big breaker panel, you place smaller smart modules near the equipment, and they then all connect back through a data network to a digital screen. From that screen, or even your phone or your tablet, you can control everything on this boat. Now, because the switching modules are distributed around the boat, the length of wiring you need in the boat is greatly reduced. That's going to make the boat much, much lighter and also easier to build. On a large boat, they can save hundreds of kilograms. Spirit Animal recently did a video and they, on their 45-foot boat, had over 700 kilograms of wire.
That is massive.
I don't know how much this weighs or how many feet of wire this is, and it's mind-blowing seeing it all in one big pile because no one would ever expect this many wires to be on a sailboat. This really puts everything into perspective. 702.1. That is the number. Wow, that's heavier than I thought.
Because it's digital, it's much smarter than just turning things on or off. You can automate groups of devices. So you can use one button to turn off all the boat lights, or a single leaving the dock button might power up your navigation screens, radar, engines in sequence. You can also create trigger-based conditions, things like if it gets dark, turn the anchor line off, or even more complex things like if the sun is shining, the batteries are nearly full, but your water tanks are low, use the spare power to make water. And you can constantly monitor every piece of equipment in the boat. Day to day, a digital switching system makes the boat simpler to operate and to manage. It's also safer, smarter, and more reliable. There are three main flavours of marine digital switching systems. They all perform the core functions of digital switching, but in our case, we also wanted to be able to incorporate our electric propulsion control. All of the three ecosystems provide for basic engine monitoring, so you can listen for the engine data and display it. But to control our propulsion, I also need to be able to transmit data so that I can tell our electric motors and our other propulsion components what to do. And only EmpirBus gave us that flexibility. It also allowed me to create custom messaging so I could communicate with our electric motors and throttles, because both of those had proprietary ways of communicating and talking to each other. Here's what the hardware looks like, but the real magic sits in the software that ties all of this together. At the base level is Logix. Logix handles all of the heavy lifting, things like the fuses, powering the devices, collecting sensor data, running safety checks. It's really that logic engine. One thing I really like about the EmpirBus system, the Logix, is that it's a visual coding format. You can literally see how the data flows from the input to the output. It starts off pretty simple, like a pump switching on or a light activating, but then we add alerts, automation, scale it up. And right now, including my propulsion, my system has over 2,300 components running it. The next layer is graphics. This takes all of that logic and makes it visible and usable. It's what puts the buttons and gauges on the screen. It looks simple, but making a good user interface is hard because you want to make all of that complexity effortless to use and intuitive, so you don't need this big, thick manual. So understanding the components and the logic is important, but it's only half the story. What really matters is what it feels like to live with the system day to day. So let's step on board and I'll take you through a simulated day in the life on our boat. First job you have is to power up all your devices.
All right. Here we go.
And on a big boat, that means flipping a lot of breakers and also having to decide, what do I really need right now?
Some of them, it's critical that they're turned off when you're on the dock, or turned on when you leave the dock, or turned on or off when you're on the hook. And usually it's one person that knows the secret combo of what you want to have on and off on the boat.
With a digital switching, I can group the devices. I call these boat modes. I have one button that powers everything you need, but nothing more. Whether you're staying at anchor, but you're on board, or you're about to start cruising, a single button press turns all the relevant equipment on, and a single button press turns everything off. You don't have to wait until you're at the boat because you can actually remotely access your boat. So as you're coming up to the dock, you can power everything up remote from your phone. So the lights are on and you've got the aircon on that's cooled the boat before you even get there, which is perfect after a hot day exploring. Of course, I wanted to also protect against accident, whether it's your kids tapping buttons or you slip your finger. That's why for critical commands, I've added a press and hold. So you have to press and hold the button for 3 seconds for the actual command to go through. I wanted to make it natural to use. Instead of cluttering the screen with extra text, the button itself gives you that visual cue. So when you press it, you see a 3-second timer, and when you let go, it either turns on or off. This is a nice, elegant way of adding in some user guidance without adding more clutter. Now, once the boat's powered up, the next step is making sure everything is working as it should. That's where this system then makes life simple. The key information and alerts are always visible at the top bar on every page. You've got no alerts at the moment and the batteries are sitting nicely at 75%. If there were alerts, they'd look something like this, and they'd be visible on all pages all the time. When I designed the interface, I tried to mirror some of the more modern things that people are familiar with, like your phone. Now that we're on board, everything looks okay. We're keen to get a little bit more information on our power use, so use the main navigation bar at the top to go to the power page. You can see the solars coming in and the full energy balance of the boat. You're generating more than you're using at the moment. What you'll see on this page and all of the main pages is that it only has the information that you need to know without drowning you in detail. You really don't need every voltage and amp. You just want to know what's coming in and what's going out. If there's an issue, the system will let you know. You'll see an alert immediately, and you can use that alert to navigate to the more detailed page. On the details page, I can see all of the data available to me from the underlying systems. Everything I need to either diagnose the problem or to at least know which device needs further testing, and I can actually go to my physical equipment and dive deep. Now, even if you don't have an alert, you can still access all of the gory details. You can go through the settings menu. Now let's get back to our day on board. You've got guests today.
And you take insanely long showers.
So not running out of water is top of mind for you. You can see that you've got 2 freshwater tanks, 2 fuel tanks, 2 grey water tanks, and 4 small black water tanks for the toilets. The overview page shows them all at a glance, along with the buttons to fill them, dump them, transfer between them, and all the indicators to show the status of the different things. You can see that the black water tanks are nearly full, so that means you're going to have to dump them. You can't just dump your black water anywhere, so you can hold it, and then when you get offshore, you can then manually dump the black water. Or if you're on a passage offshore, you can leave it on automatic, and as soon as it's full, it will dump. Next, you notice your bilge system on the right-hand side. If you're not familiar with boats, the bilges are the lowest part of the hull, and there are pumps installed in those areas to get rid of any water that makes its way inside. In our case, we've got 8 pumps, and they're spread across the 2 hulls. And on the screen, you can see that the indicators are mostly grey, which means the pump's off. But one is on, and one is off currently, but it's been running recently. It's got number 4, which means it's run 4 times in the last hour. Water intrusion can be a critical emergency situation in a boat.
This is cargo vessel Seaqueen. We're 55 degrees, 12 minutes north. We're taking on water. We're abandoning ship. I repeat, abandoning ship.
But in this case, it's not a red alert situation. If it were, you'd see like warning signs on every screen, you'd hear an audible alarm, and you'd even get a NEMA alert across the boat network and on your phone. What I wanted was to create a system that would let us know that things are going awry before they become critical. Program in different bits of information and data that it will collect and monitor, and if anything seemed out of place, the system will let you know so that you can actually go and investigate that early before something small becomes something really, really big.
Data. I need data. What causes this flux and where does it start?
That same approach runs throughout the boat. The system is constantly looking for early warning signs of impending failure. Behind all that monitoring, I've added in layers of safety, rules and interlocks that stop the boat or user doing anything that would make a situation worse. For example, say our battery starts to heat up a little bit. First, the cooling system will automatically kick in. If that doesn't bring the temperature back under control, the propulsion system reduces the engine for lower output. If the heat continues to rise, the engine's then shut down entirely and can't be restarted until it's safe.
I can't do that. It's my job to protect you.
The same principle applies to all the critical systems on the boat. The system won't allow you to turn them on if conditions aren't right. If everything's not A-OK, you can press the button, but the system is going to go no. In fact, it'll then flash up a message to say why. And that's a big core principle throughout the design. The system is made to actively monitor and protect itself.
Thank you, sir.
You forgot the water.
Sorry, I'm making a point.
Limits are there for safety, but they're also useful for other scenarios. They can make everyday tasks simpler. Now that you've got guests, you want to actually have maximum amount of water. So you go to your screen and you increase your desired fill level. And the system will take care of the rest. It will run the water maker until the tank is at that level. And if you leave it in auto mode, it will automatically top up the tanks whenever you run low. So you don't have to think about it again for the whole passage. The system monitors itself and stops and starts as needed. Now it's getting a little bit darker. You might want to set up a bit of a cozy atmosphere for your guests. So one tap, you turn your lights to warm tones on the main deck. If it's time for dinner on the flybridge, you can switch to bright mode, and the table is well lit. If your guests are keen to fish, you switch on the blue underwater lights and your fishing station lights up as well. In a boat this big, we have many, many lights. Everything's grouped together, so you don't have to think about which ones to toggle. You just choose what scene or mood that you want for each area of the boat. Having grouped control of the lights is really convenient, but I've also made sure that you can actually have full control of every light. At some point, someone's going to want a light on or off that isn't in the scene selection. Navigating through to the detailed light page, you can see that every light you can control, whether they're on, off, and if it's dimmable, you can adjust the dim level. And that's really important, not just from the perspective of giving user individual control. I really thought about when I actually just set up this boat. Your LED light all had to use different levels of current, and to get the dim levels all exactly right for our mood selections, I'm going to have to manually adjust them. So rather than having everything hard-coded in the back, having to adjust the dimness, reload the software, adjust the dimness, reload the software, which is way too much work. Being able to adjust the dimness on this page means that I can set everything up perfectly the way I believe that a scene should be. I can then go back and get that and hard code those into our automatic scene selections. The same thing with the tank sensors.
It's a pretty simple device that works by changing the sensor values based on this little floaty part to tell you whether the tank is full or empty.
They need calibration when you first install them, and also they drift over time. So what point is full and what point is empty? That signal, the data that feeds that, changes a little bit over time. So rather than having it all coded into the back end, I've added a tank calibration page, which then allows you to select each of the different tank sensors and record the minimum and maximum levels, which will then be saved in memory. I will put a pin code on this particular page because once these sensors are calibrated, we don't want a normal user to be adjusting these at all. What really sets this system apart is that it doesn't just manage the boat systems, it drives the boat itself. Propulsion is where digital switching really meets the solar electric design of our boat. It's the part that I'm really most excited to show you. So the first thing to understand that all solar electric cruising boats are hybrids. So just like sailboats have a diesel or sometimes electric engine to back them up when the wind doesn't blow, all solar electric boats have some sort of diesel backup to generate power when your batteries are flat or when you're trying to go faster or further than your batteries are able to be recharged by the sun. Now there are two ways you can set this up in a solar electric boat: serial and parallel. In both cases, solar charges the batteries and the batteries power the electric motors. The serial hybrid option is what the Silent Yachts brand uses. That's the OG solar electric cruising boat. In a serial setup, when the batteries run low, a diesel generator kicks in and recharges the batteries, or powers the motor by providing power straight through the batteries to the motor. It's called a serial hybrid because all the key components run in a series: the generator to the batteries to the motor to the propeller. The other option is parallel hybrid. In a parallel setup, the solar still charges the batteries and the batteries power the motors. But in this configuration, the backup diesel motor is directly connected to the drivetrain using a clutch. That gives you a lot more flexibility. You can still run the diesels purely as generators, just like in the Silent Yachts, recharge the batteries, but you can also use them to directly propel the boat. It's called a parallel configuration because the diesel and the electric motors can work independently, but they can also work together in parallel to propel the boat. This approach also adds a layer of redundancy. In an emergency, say a lightning strike knocks out all of your electrics,
the lightning destroys all my electronics,
or you have a battery fault.
Whole boat lost 12 volts, so got no idea what that means, but that's not a good thing.
You can still operate a parallel hybrid boat in pure diesel mode. You're never stuck without a way to get to safety. In a serial hybrid, if your electrics or your batteries go down, you're dead in the water. Now there's pros and cons to both the serial and parallel configurations, and we really spent a lot of time going back and forth which one we were going to choose. In the end, our boat is a family cruising boat and safety had to come first, so that redundancy of having that parallel configuration really won out. The propulsion is really the most complex system in our boat. It looks simple in a schematic, but really behind the scenes there are dozens of systems and components working together. They all need to talk to each other, listen to each other, and operate together seamlessly to make this work. And on top of that, I've had to add layers of safety and redundancy, interlocks, rules that prevent anything bad from happening. But as a user, you don't need to know all of that underlying complexity. I wanted this system to feel simple to use, a natural extension of how you would operate a diesel boat. So at the helm, you've got a single set of throttles, a simple propulsion screen. For this example, the boat's in 100% electric mode, which is what you'll be in 95% of your cruising life on your solar electric yacht. You can see you're in 100% electric mode because your propulsion mode button at the top center of the screen shows 100% electric. Also, the visual of the boat in the middle shows the batteries and the power flowing to the electric motors, and then these are connected to the propellers. This boat visual is dynamic, so it updates to show you the current situation for all of the core propulsion components and which direction the power is flowing from your battery. This visual really gives you a sense of what is actually happening, at least at a high level. I wanted there to be a single propulsion page with just one interface to get used to and one interface for controlling the propulsion, no matter which mode you're in. And to do that, I needed this to respond dynamically. A big design principle for this page, and really the whole system, was carefully considering what information is the most important to show. Not everything is equally important when you're running the boat.
Those filters ingested everything. They were drowning in data. It was a disaster.
On a solar electric boat, 95% of the time you're in 100% electric mode. So what really matters on the propulsion page, other than your speed, is the energy balance of the boat. That's why right here, alongside the speed, I've added an energy balance dial. It basically tells you, are you using more power than you're generating, or are you generating more than you're using? Its purpose is to give you an instantaneous feedback on how your speed is impacting your net power use. That's important because every extra knot comes at a cost. If the passage is short and it's a nice sunny day, cruising along at 12 knots is a great use of all your spare power. Other times, if you're going a longer distance, or it's raining, or your solar generation's a bit lower than normal, you might want to actually take your time and conserve your battery. The choice is yours, but having that information available front and centre gives you that information you need to make decisions on the fly. Indeed, that's also why I added a measure of range to minimise the maths that you need to do. Now, like other pages in the system, this propulsion page is also just got the most critical information. There's a second, more detailed engine diagnostics page that provides full details and the data for diagnosing any issues. If there's some sort of alert, you can access that detailed page directly through the alert icon. If there isn't any issues, then you can go through the settings menu to access it. So now let's get back to the fun of cruising along in our boat. We've been going up the coast all day. Now we need to cross the Wide Bay Bar before anchoring for the night. There's a reason they call it the Mad Mile, and you don't want to take any chances. The safest option for cruising a bar is to ride the back of a wave. To do that, you're going to need to go fast, so you activate boost mode.
Let's punch it.
Boost mode is where we close the clutches and bring the diesels online. So their power adds to the electric motors for a combined 427 kilowatts per hull. And that gives us an estimated top speed of around 25 knots, up from 15 if we were just using our electric motors. And that's another advantage of our parallel configuration, the ability to get the diesels to support the propulsion, not just to act as a generator. But we have even more flexibility than just this. With the clutch closed, we can also operate in regen mode. In that case, the electric motors absorb some of the power of the diesels and can recharge the batteries. It's quite common in electric sailboats, but it sounds crazy in a power cat. But in a parallel configuration, it actually does make sense. We can generate power and actually use less fuel than if we run without regen. Crazy, right? Let me explain. Diesel engines have a sweet spot. They're most efficient at certain speeds and loads. So if an engine is just ticking along at say 1500 RPM, it's actually burning more fuel than it would at peak efficiency. In our case, that's between 2000 and 2200 RPM. So by switching the electric motors into generation mode, we make the diesels work a little bit harder to maintain the same boat speed. And the result, we generate around 127 kilowatt hours of energy while burning 10% less fuel than running the diesel alone at 1500 RPM. The way I've implemented this in our system is combining boost and regen into what I call a smart hybrid mode. In smart hybrid mode, the system constantly balancing the loads. The electric motors add power when you need extra speed, or switches to generation when there's spare capacity and we need to load the engines higher, always keeping the diesels running right at their most efficient point. It's all handled dynamically in the background.
That's brilliant. It's what I do. But wait, there's more.
We still have our diesel backup. You can choose it directly on the screen if the system is up, but the system will also automatically fail over to pure diesel mode if the batteries or the electrics ever stop working. In pure diesel mode, the clutch is closed, the electric engines just sit passively on the drivetrain. Lastly, there's also a generate-only mode. Now, not technically a propulsion mode because the propellers don't spin. In this case, all the diesel power is sent straight into charging the batteries. With both sides of the boat running in generator mode, we can charge the batteries from 0 to 100% in 1 hour, all while staying inside that 1C safety charge limit that we put on our batteries. That parallel setup gives us incredible flexibility. Each hull can run in its own mode. So if you include the off state, that means the boat can be running up to 25 different possible combinations. What you might notice is that not all the propulsion modes are showing. The core modes are shown, where both hulls are operating in that same mode, but the split modes, where each hull runs on a different mode, live in a sub-menu, where you can choose each of the modes independently for each hull. That keeps the interface clean and clear for day-to-day use, but it still gives you full access to a deeper control when you need it. So the system also has to manage a smooth transition from any one mode to another mode. Mode change involves a lot of moving parts. The current mode has to shut down safely in a controlled way. Everything needs to switch over and then the new mode needs to start up safely. Making that seamless for the user took some really careful coding and interface design. As you might expect, there's a lot of safeguards and checks being done in the background to make sure that this change is safe to do. Say you went to switch from your 100% electric to smart hybrid, but change your mind and press back to electric. The system is going to allow that. Once a mode change has been initiated, it's a very controlled sequence of events. We don't want to suddenly, mid-event, try and swap back. So the system will actually tell you, please wait till the current change is completed and then you can change back to another mode. I wanted the system to give you that guidance in the moment, so you didn't need that thick manual. It would guide you as you need it. And really that's the story of this whole project. A yacht control, electric propulsion system, tightly integrated, robust, and with safeguards built in, all wrapped up in an interface that feels natural and easy to use. Because in the end, this was never about the software or the systems they control. Our goal was really bigger. It was to build a solar electric boat for our family to live on and travel the world. The next milestone for us is sea trials. This is just the beginning of our journey and I'd love for you to follow along.